Aston Martin may be hiding the most explosive engine story in Formula 1. Honda has reportedly found around 40 horsepower for its new Aston Martin power unit, a gain big enough to affect acceleration, overtaking, qualifying, and the entire design of the car. But that is not the shocking part. The real mystery is how Honda found that power, because the available report does not reveal whether it comes from the combustion engine, the electrical system, improved efficiency, or a combination of all three. And if Honda has achieved this without creating major problems with heat, reliability, or weight, Aston Martin may be building something far more dangerous than its rivals expect. Because this is not just an engine upgrade. It could be the breakthrough that changes the entire balance of power in Formula 1. Subscribe to the channel. To understand why this reported 40 horsepower gain matters, you have to look beyond the engine itself. Because Aston Martin is not simply trying to bolt more power into the back of a Formula 1 car. It is trying to build an entire machine around Honda's new power unit. And that changes everything. A Formula 1 car works like one connected chain. The engine affects the cooling. The cooling affects the bodywork. The bodywork affects the airflow. The airflow affects the grip. And the grip affects how early the driver can press the throttle. So when Honda reportedly finds around 40 horsepower, the effect does not stop at the end of the straight. It can influence almost every major decision Aston Martin makes. But there is one important detail. The available source gives the reported 40 horsepower figure, but it does not explain how that number was measured. It does not reveal the comparison point. It does not say whether the gain comes from the combustion engine, the electrical system, improved efficiency, or several developments working together. And that missing information is not a small problem. It is the key to the entire story. Because maximum power and usable power are not the same thing. Imagine two drivers accelerating away from the same corner. Both press the throttle at almost the same moment. For the first few meters, the cars appear equal. Then one begins to move ahead. The gap grows slowly at first. By the end of the straight, one driver may be close enough to attack, while the other is already under pressure. That is what extra power can do. But only when the driver can actually use it. If the power arrives too aggressively, the rear tires can lose grip. If it creates too much heat, the team may have to reduce performance. If it cannot be sustained, the advantage may disappear before the most important part of the race. And this is where the reported Honda upgrade becomes much more complicated. 40 horsepower for one brief moment is impressive. 40 horsepower that can be delivered smoothly, reliably, and repeatedly is something completely different. That is the version Aston Martin needs. The engine must work when the car is heavy with fuel. It must work when the tires are worn. It must work when the temperature rises. And it must work when another driver is close enough to attack. Formula 1 does not reward a power unit for producing one perfect number. It rewards the complete package for surviving pressure. Think of a runner who can produce one explosive sprint. For a few seconds, the speed looks extraordinary. But a Grand Prix is not one short sprint. It is repeated acceleration, lap after lap, while heat builds and every component is pushed closer to its limit. The strongest burst means very little if it cannot be repeated. And Honda's challenge is not simply to create more power. It is to create power Aston Martin can trust. That word matters. Trust allows the driver to press the throttle earlier. Trust allows the driver to attack without waiting for the rear tires to settle. Trust allows the car to feel predictable when the grip begins to disappear. Without that confidence, even the strongest engine can become difficult to use. And hesitation costs time. Sometimes only a fraction of a second. But that fraction can decide whether a driver completes an overtake or remains trapped behind another car. It can decide whether the car reaches clean air. It can decide whether the tires stay under control. And it can decide whether a strong race becomes a frustrating one. But there is another problem hiding behind the power figure. More power can create more heat. More heat requires more cooling. More cooling requires more space. And more space can change the shape of the car. That sounds like a small engineering detail. It is not. Every opening in a Formula 1 car affects how air moves around the bodywork. If Aston Martin needs larger cooling areas, the engine may remain safer, but the car could become less efficient through the air. The team could gain speed from the power unit, then lose part of that advantage through aerodynamic resistance. It is like opening the windows of a fast-moving road car. The cabin becomes cooler, but the airflow becomes less clean and the car has to work harder to move forward. Aston Martin must avoid that trade. Honda can provide the performance, but the chassis team must protect it without damaging everything around it. And that is why this reported upgrade is far more important than a single number. If Honda has found around 40 horsepower without creating a major cooling penalty, Aston Martin may gain something even more valuable. Freedom. Freedom to shape the car more aggressively. Freedom to choose aerodynamic settings that create more grip. Freedom to attack on the straights without sacrificing as much performance through the corners. And freedom to build around strength instead of constantly protecting a weakness. That could change qualifying. It could change overtaking. It could change tire management. It could even change the way Aston Martin approaches race strategy. One advantage can create another. More power can support a higher grip aerodynamic setup. More grip can improve cornering speed. Better cornering speed can protect track position. Track position can reduce time spent in traffic. And less time in traffic can help control tire temperatures. That is how one engine development can spread through an entire race weekend. But the same chain can move in the opposite direction. More power creates more heat. More heat creates more cooling demand. More cooling demand changes the bodywork. Changed bodywork can reduce efficiency. Reduced efficiency can increase tire stress. And increased tire stress can destroy race pace. The reported 40 horsepower gain could become a breakthrough. Or it could create a new set of compromises. That is the tension Aston Martin cannot escape. Because the source tells us the number. It does not tell us the price. And until we know what Honda had to change to produce that performance, the most important part of the upgrade remains hidden. Not hidden because there is proof of a secret operation. The available source does not establish that. Hidden because the technical context has not been provided. That missing context is exactly what rivals would want. They would want to know how often the power can be used. They would want to know how much heat it creates. They would want to know whether it changes the car's packaging. They would want to know whether the electrical delivery remains strong at the end of the straight. And they would want to know whether Aston Martin can use the full performance during an entire Grand Prix. Because if the answer to those questions is yes, the reported 40 horsepower may be only the beginning. The real advantage would be the complete car Honda's engine allows Aston Martin to build. And that leads directly to the next problem. Honda may have found the power, but Aston Martin still has to prove it can control it. Controlling that power is where Aston Martin's real test begins. Because once Honda provides the performance, every other part of the car has to respond. The driver needs traction. The tires need protection. The gearbox needs reliability. The cooling system needs enough capacity. And the aerodynamic package needs to remain efficient. If even one of those areas struggles, the reported 40 horsepower gain can begin to lose its value. That is why raw power can be deceptive. A stronger engine can make a car faster on a straight. But a Formula 1 lap is not one straight. It is a sequence of braking zones, corners, acceleration points, energy demands, and tire movements. The car must perform through all of them. Imagine carrying a full glass of water while running. Moving faster sounds helpful. But the faster you run, the harder it becomes to keep the water inside the glass. That is Aston Martin's challenge. Honda may be increasing the speed. Aston Martin must make sure the rest of the car stays under control. And the first place that control can disappear is at the rear tires. When a driver leaves a slow corner, the engine sends force toward the rear wheels. If that force arrives too suddenly, the tires can begin to slide. The driver then has to reduce the throttle. And the moment the driver lifts, part of the power advantage disappears. This is why delivery matters as much as output. A powerful engine that feels smooth can help the driver accelerate earlier. A powerful engine that feels aggressive can force the driver to wait. That delay may be tiny, but Formula 1 is built around tiny delays. A fraction of a second leaving one corner can become a much larger loss by the end of the straight. And when that happens repeatedly across a lap, the numbers begin to add up. So the most important question is not simply whether Honda has found around 40 horsepower. It is whether Aston Martin can convert that power into earlier throttle, stronger acceleration, and consistent lap time. That sounds obvious. But it is one of the hardest things to achieve. Because the driver is not always working with fresh tires. As a race continues, the tires lose grip. The car becomes harder to control. The rear end may move more under acceleration. and the driver must become more careful. An engine advantage that feels manageable in qualifying may become far more difficult to use late in a race. That is where the true quality of the package appears. Can the power remain smooth when the tires are worn? Can the driver still trust the car? Can the engine continue delivering performance without increasing wheel spin? Can Aston Martin protect the tires while still using Honda's strength? Those answers could decide whether the upgrade improves race pace or only creates an impressive headline. But there is another layer. The gearbox must also handle the added demand. The available source does not provide any detail about gearbox changes, durability, or how Aston Martin plans to manage the reported increase. That information remains unspecified. But the principle is simple. When more force passes through connected components, those components must be prepared for it. A stronger chain is only useful when every link can survive. The engine may produce more power. The gearbox must transfer it. The drive shafts must carry it. The rear tires must use it. And the driver must control it. This is why Formula One performance is never created by one department. It is built through cooperation. Honda may focus on the power unit. Aston Martin may focus on the chassis, but the final result belongs to both. And this partnership creates an unusual kind of pressure. If the engine is strong, Aston Martin has fewer excuses for weak acceleration. If the chassis is efficient, Honda has fewer excuses for poor overall performance. The closer the project becomes, the more clearly every weakness is exposed. That can be uncomfortable, but it can also accelerate improvement. When teams work around a shared system, problems can be identified earlier. Engineers can see how one decision affects another. Cooling demands can be discussed before the bodywork is finalized. Power delivery can be adjusted around the needs of the driver. Packaging choices can be connected to aerodynamic goals. That is the advantage of building the car and engine as one idea, but only when communication works. If Honda and Aston Martin disagree about priorities, the project can become trapped between two different goals. Honda may want safer temperatures. Aston Martin may want tighter bodywork. Honda may want to protect reliability. Aston Martin may want maximum performance. Honda may prefer one type of power delivery. The driver may prefer another. Every choice can create tension. And that tension will not disappear because the headline number is exciting. It may actually become stronger, because when an upgrade is described as a major breakthrough, nobody wants to be the reason it cannot be fully used. That can push teams toward risk. And risk is where championships can be won. It is also where races can be lost. Aston Martin must decide how aggressively to operate the power unit. Using more performance may improve qualifying, but it may also increase stress. Protecting the engine may improve reliability, but it may reduce the advantage that created the excitement in the first place. That balance will matter across every race weekend. In practice, the team can study temperatures. In qualifying, it can push closer to the limit. In the race, it must think about endurance. The same power unit may need to behave differently in each session. That is why one maximum figure cannot tell the whole story. A reported 40 horsepower gain may describe what the system can achieve,